Since this radio is completely mute on all radio bands, short wave, medium wave, long wave, I have decided to check intermediate frequency part and all oscillating circuits in first and second intermediate frequency stage, and to see if they are tuned to the right frequency. This is the first stage, that one over here. It has two coils, and this is the second one. This is the second stage, just before demodulating the signal and before audio frequency amplifier. You can see two tuning capacitors over here and two coils, and I will show you where is that on the schematic. So that is right over here. This is the first capacitor and this is the second tuning capacitor. It has two coils with the core, and this is what I need to determine on what frequency it's actually oscillating. I have managed to find some factory data, and it should be oscillating at 482 kilohertz, the same frequency we have for the first stage. But before starting with tuning those oscillating circuits, we must make sure that automatic frequency control is turned off, and that is actually extremely simple to do. All we need to do is to short out this capacitor here with the ground. So I will connect this point with the ground, and this is actually the way that we are turning automatic frequency control off. And we always start with tuning the second intermediate frequency coils, oscillating circuits actually. So how are we going to do it? The first thing I'm gonna need is a function generator, and I will show you that over here. This is a function generator. Right now it is set up to give a signal of 515 kilohertz. It's with the amplitude modulation. It's modulated at rate of 30%. It has amplitude of 4.5 volts, duty cycle of 50%, and that is pretty much it. One more important factor is that it's being modulated with a signal of 400 hertz. And of course we have a scope here. And what are we going to monitor with this scope? It's quite simple. It's connected with the loudspeaker. So we're going to monitor the amplitude on the loudspeaker, and what we expect to hear is a 400 hertz signal in the loudspeaker. And now let's see where is that connected. So the signal generator is connected with the grid 1 of second stage amplifier. So this is EBF11. It's intermediate frequency amplifier, and we are connecting signal generator with first grid of this tube, and that is it. So now I will turn the radio on. Generator is sending signal right now. It's connected here. So this is the setup for the signal generator, and that is first grid. I have marked it with G1. This is the first grid, and this is the tube over here. And now I'm going to try to find out on what frequency this coil is oscillating, the circuit is oscillating, and it's quite simple. So now let's turn it on, and we will measure that frequency. Okay, the radio is turned on, as we can see. Now all we have to do is to wait for the tubes to heat up. I have voltmeter also connected in parallel with a scope probe, so I will try to measure the voltage as well. And again, the main purpose is to determine on what frequency it's oscillating. As you can see, signal is slowly appearing. There it is. So remember the setup. It's on, let's see, it's on 50 millivolts. So each square is 50 millivolts. Now what I'm going to do is to change the frequency and to monitor the amplitude at the same time. So let's see where the maximum is. Just turn the volume a bit down. It's at 521 kilohertz. This is where the amplitude was at the highest level. I will just lower down the amplitude, let's say 3 volts. Now turn on the volume. It's still loud. Okay, 2.5, this is something that I can work with. And now let's tune the frequency again and watch the amplitude, just to focus it. This is where the maximum is. Yeah, it's 522. 522. So it's actually way off. It's way off 482 kilohertz that we need. So what I'm going to do now is that I will use one capacitor and connect it in parallel with this capacitor here, so I could lower down the frequency. Let's see if it's set to the maximum anyway. Yeah, that should be somewhere over here. I will show you the amplitude now on the scope while I'm turning around this capacitor. Yep, so this is the maximum. I'll turn it off now. It's the easiest way at this moment to me. Okay, so as you could see, this part, just to check it. Okay, we have focus. This part over here is oscillating at 522 kilohertz. In order to pull down this frequency, I will connect one capacitor in parallel over here, and we will see how much that is going to lower the frequency. Since this capacitor here has 140 picofarads, I will try to use something like 10, 20 picofarads to see how much lower I will get the frequency. And just remember the parameters that we had. So you remember what the amplitude was, and over here we had 522 kilohertz and amplitude of 2.5 volts. So let's add this capacitor and see if we're gonna get any change. Okay, so now we can try again. The radio is on. I will just adjust the scope now. We will wait for the tubes to heat up, and let's see if we did any significant change. There's the signal. I forgot to measure the voltage at first time, but now it's giving like 0.08 volts. Okay, it's quite lower. You can see that just by watching this this amplitude. It is the volume is at the maximum right now. So let's do the same procedure again. I will now try to get with lower frequencies to get the results, to see where we are right now, what is the resonant frequency. I'm lowering down. Okay, so it's quite loud. It's quite loud, and right now I'm at 505. Watch the amplitude. It's going way off the limits, so it's not about around 100 millivolts like it was. It's much higher now. This is something that I cannot stand listening, so I will put the amplitude down as well. Let's try with 1 volt. Okay, this is 1 volt, and now I will continue with tuning the frequency down. Still quite loud, so we're going below 1 volt, 0.5, and now continue again with lowering the frequency, and this is where the maximum was. Let's try with 0.6. Okay, now tune the frequency. $497. 497. We need to get a little bit more down. Okay, so you saw the procedure, and what I'm going to continue doing now is to adjust the capacitance here, to add a new capacitor, maybe a couple of more in series, and we will see. So the aim is now to get to 482 kilohertz in this oscillating circuit. Now you could hear how much higher and louder is the volume at the loudspeaker. So we're at a good track. And when I finish with second stage, then I will continue adjusting the first intermediate frequency part the same way as I did with the second one, and only after that I can go to adjusting input oscillating circuits and filters we have here, and hopefully we will have a nice and good reception at this radio receiver. So now let's just continue with experimenting with capacitors and see what will be the right capacitance here, and then we will see what's going to happen with first intermediate frequency part and input part. Now we can make some conclusions. You can see that I have added here in parallel this one small capacitor. It's 20 picofarads. I will show you on schematic where it is. It's over here. So I have just added another one in parallel with this circuit, and below you can see this 30 picofarads adjustable capacitor, which is also added for another oscillating circuit for this one over here. Just to focus it again. Yep, for that one over here. And now we have adjusted this intermediate frequency oscillating circuit. Now pay attention to the amplitude. Actually, the frequency is set to 482 kilohertz, and this is the frequency we want to have in intermediate frequency. And now pay attention to amplitude. As I said, it's just 0.35 volts, and it was 2.5 volts when I started this adjustment. So now I can be sure that this circuit is adjusted as it should be, And that is actually pretty much it. So I can move forward to the first intermediate frequency part, and the process of adjustment is absolutely the same. Now, if you take a look at the scope, you will see that the signal now much more resembles to the sine wave. It was quite deformed previously, so we have one nicely working intermediate frequency part, and I can move forward. So now I will be adjusting the first stage to see if that oscillates well, and after that I can move to antenna and input filters in the antenna part. So now that would be obviously it. Maybe a little bit more of tuning, but radio is finally working. It's able to tune radio stations. This is a shortwave band, I think. So yes, it's definitely working. Audio is quite low. Maybe audio tube is bad, but the major problem is actually fixed. I can tune radio stations now, and I'll deal just a little bit of tuning these coils. It is quite simple, and that would be pretty much it. Now, I hope that quite soon I will put back this radio into its cabinet. Maybe I will try again AZ11 instead of these BY diodes that I'm using here, to see if I can get it back to the original state as much as possible. And I can say that I'm quite satisfied that that I have now this radio working, and it was absolutely mute, not a sign of life. So that would be it, and I will later show you how it looks when it's fully assembled. And soon I hope that I will continue this with another radio, so stay tuned.
Oil products, and also the country's economy has been growing so slow that it is not able to create enough jobs for the young people, which numbers are growing and are increasingly restless. So that's why you do have kind of a protest young people. And also, the economy should be growing at 6% in order to actually, it was